Okay, so today I spent quite a bit of time trying to kind of understand how I can redesign the application. Initially I wanted to kind of take a look at how I can redesign the smart contract implementation. That kind of led me to trying to think about just the overall system architecture as a whole. And so I've kind of changed, I think, in some ways, I've changed the way that I want to kind of architect the system as a whole. So we've got a front end application. Okay, now this is essentially uh, for data capture. So the user, let's say the supply chain actor, submits a form. Maybe this is to, so this kind of example is creating a product on the blockchain. So the user submits the form with the relevant data. It goes to my backend server, right, so via an API request. This information is then passed on to the smart contract. So I'm going to have obviously the libraries in place in this backend server to be able to interact with my smart contract, and it's going to call a specific function to create the product on chain. The smart contract is then going to store the data, right? So it's going to store very basic information such as the product ID and a few other things, and then it's going to emit some event data back to the backend server, and then that will go back to the front end for kind of display purposes. Now, if if we're looking at how actual data about the product is being stored, then the user submits a form. It goes to the backend server, and then this this then goes to the IPFS client that I'll be running, and the data will be saved, and then a CID content hash will be returned to the backend server. This this hash is then what is going to be stored in the smart contract. So I'm not going to store the actual event data in the smart contract itself. It's going to be probably a array of hashes. So that way, what the blockchain is doing is it's providing a permanent and tamper-proof record of what happened without having to actually store the data about what happened itself. So it's more about digitizing the asset, tracking the ownership of the asset, as well as storing the event hashes, which can then be used to figure out or to retrieve the actual data. So that's the kind of role that the smart contract or the blockchain is playing in this application. I've also got a component here, product DAG. So DAG stands for Directed Acyclical Graph, and it's a type of graph that has no loops. So what I mean by this is one of the issues that I was having. I remember now when I was first kind of coming up with this. When I was first building out this application, was that let's say you had a whole animal, you can record event data based on what's happened to the animal, let's say at the farm. But then what happens when the animal is slaughtered and then taken um, to the processing plant, right? It's likely that the animal is going to be cut into various different pieces. So maybe you have cut one, cut two, cut three, cut four. Now at this point, there's a fundamental transformation of this animal, and it's now become a different product almost with a different path or a different event history that's going to take place. So I think I ended up just not implementing it, um, and and obviously I kind of got away with it because it was a very basic, rudimentary implementation. But the way I'm thinking about it is if I can store the animal or the product IDs in a graph like this, then I can record the relationship between products, or the lineage of a product, uh, in a in a way. Well, I can do it off chain, right? I don't have to do it on chain because if I was to do it on chain, I would need to probably have a bunch of mappings that would map a product to its child products. Each time I wanted to add a new product, I would have to query this mapping. I'd have to update it. I'd have to actually write to the blockchain, which is expensive. And then even if I wanted to just read it, it's still a fairly expensive operation in terms of kind of computation. So it makes sense to leave out this kind of relationship between the products, um, to a backend server. Now I can do this myself. I can implement my own kind of mini graph for each product, and so each product will be linked to its child products. So this whole animal product here will have 4 children, and then this first child will be the final product, right? So maybe this is um, I don't know, maybe the whole animal is a cow, and it's kind of cut into 4 pieces, and now I don't know, maybe this is an entire, or let's say this is a lamb. Maybe this is one of the legs, right? And the final product itself is the leg, right? So this lamb so event data about this lamb will be recorded up until the point that it is cut into various pieces. Then a new product will be created on chain with a new ID. And then essentially you're looking at the history from here to here, right? So what's happened previously is almost kind of out of the picture. The same thing happens for these next 3 cuts, right? So a new product for each of these cuts is created, and then maybe all 3 of those are used to make some sort of product. So maybe this is ground lamb, mince, right? And it's taken all the cuts from um, it's taken cut 2, 3, and 4, and it's been processed into, I don't know, burgers, let's say. So the way I'm thinking is that if I do it this way, if I have a final product here with an ID, I can figure out who its parent is, and I can figure out who its parent is, and I can trace the final product back to the cut, and then finally back to the animal itself. Likewise, with this, I can figure out, okay, who are the parents of this product, of these burgers. I can see that, okay, it came from cut 2, cut 3, and cut 4 of this animal. Maybe, let's say, maybe you've got 2 animals, and let's say it was like this. All right, let me just move this. So let's say this whole animal was cut into 2 pieces, and each of those was a product in itself that was sold, right? So maybe it was a, a cattle that was cut in half. Now, they're both sold as a half of a cattle, a half of a cow, and that is the final product that's sold and then sent over to the retailer. And maybe this whole animal is cut up into 3 parts, or let's say you have even another animal, and let's say that's cut into 2 pieces, right? And maybe let's just say, for example, um, this process product contains 3 cuts from this animal and a cut from this animal. You can like you can trace it back, um, hopefully with this type of structure. So I hope that makes sense. I'm not sure exactly how I'm going to implement it yet, but this is just my thought process. If each one of these nodes essentially just contains a product ID, um, then in theory I should be able to track products kind of forwards down this or along this graph, and I should be able to also trace it back, um, kind of back up and see what parents it came from. So that's what this product DAG is. Like I said, it's a component of the backend, but I just thought I would separate it out here so you can kind of see and understand what I'm talking about. So yeah, this kind of talks about how to retrieve the information. So the user submits a form with the product ID. It then requests the product tree from my backend server, which I guess this is just a component of the backend server. It returns the product tree. Now, this product tree contains all the IDs, right? It contains all the IDs of the product. So maybe it's I don't know exactly how I'll do it. Maybe it's just an array, right, in order of. Actually, I haven't thought about that, because if it's in this situation and it comes from different graphs. So yeah, I'm not 100% sure, but this is just what I kind of thought about. I'll have to see how exactly I can implement that. But then in theory the idea is, once I have the product IDs, I can then query the blockchain for the for the hashes of so the event hashes for that product, right? So the smart contract would basically contain, so for each product, so maybe it's like, I don't know, a struct, uh, if it's like solidity, for example, right? So maybe I've got something like an ID, I've got producer, whatever date created, etc. Right? So and then I've got a an array of events. Okay, and then I'd have an event struct. But anyway, so I'd query the blockchain for this event array. That would return the array of hashes that was added from this IPFS client, and then using those hashes, I would then request the event data given those CIDs, and then the event data would be returned to the backend server, which would then be returned to the front end. So that's in theory how I could query, or how I could actually get the full lineage of products, as well as the events that occurred at each stage. So yeah, not sure if there's a better way of doing it. Obviously, like I said, I kind of could represent or I could keep track of the children of each product in the smart contract itself using mappings. But like I said, I'm not really sure if that's the best way of doing it. It seems that, from what I can understand, the smart contract really has a very limited, or should have kind of a limited capability in terms of storage. And so I don't really want to mess about with too much storage. I think maybe there's a way. I'm not sure. But for now, I think this is a pretty cool idea. It does make sense in some way, and then at least from if I do it this way, I can I can make the back end more scalable. Right, it's a lot easier to make this kind of section here more scalable, as opposed to making the smart contract itself more scalable. So if I add, an API gateway, and have messaging queues, etc., to kind of be able to manage a high number of requests, I think it's easier for me to deal with on just a normal kind of standard server than it is to do that within the smart contract. So yeah, that's what I'm thinking. I'm gonna kind of refine this model and see if it makes sense, and then yeah, and then I guess I'll drill down into the smart contracts and figure out exactly what it is that what kind of functions and what kind of smart contracts I'm actually going to implement. So that was just a quick update on my progress today, and I'll see you tomorrow. We'll see what happens.